This is for Year 11 methods. We're going to look at question 14 from exercise 2C. So which of the following does the line pass through the origin? So the origin happens to be the middle of the graph and has coordinate 0, 0. So we're going to check whether these graphs pass through the origin. And the easiest way to check it is just to sub in 0, 0 to see if the statement's true. So when x equals 0, y equals 0, is that statement true? No, because 0 plus 0 does not equal 1. Okay. If I sub in 0, 0 into the second equation, you got 0 plus 0 equals, well, the x is 0, so it doesn't contribute anything, so 2 times 1 is 2. That's not true either. So if I sub in 0, 0 in the third equation, 0 plus 0 equals 0, yes, that's correct. So this one's correct so far. Next one, 0 minus 0 equals 1. That's not correct. So the only equation that passes through the origin is x plus y equals 0. And another way you can determine this is if you rearrange all these equations to turn them into y equals mx plus c form. So for the first equation, if I go y equals 1 minus x, as you can see, the c value is 1, so we know that it's not going to pass through the origin. Okay, so the y-intercept's already a 1. Okay, so the y-intercept's 1, it's not going to pass through the origin. Similar for B and D, but if we do equation C, if I rearrange it, I get y equals negative x. Now the gradient's negative 1, but the y-intercept, there's nothing there, so it does go through 0 for the y-intercept, which means x-intercept's also 0. So by default, that does pass through the origin. So there's two ways you can prove that. One way is subbing in x equals 0, y equals 0, or the other alternative method is to rearrange it to y equals mx plus c form, and if your c value is 0, then obviously it has to pass through the origin. So I hope that helps.